All right, hello everybody. We're looking at lesson 34, which is going to continue looking at the mole. Was that also the title? Hold on, I'm sorry. Was that the... Okay, 33 was the mole. Okay, all right. I'm sorry. I confused myself there, but we're good. All right, so what I'm going to do, I'm going to go right here to the periodic table. We'll open that up. We have the slides for this lesson. I have this lesson itself. And then I also have the Desmos graphing calculator. You can go to desmos.com/calculator, and we'll let this do a lot of the heavy lifting for us. Okay, so how many copper atoms are in 5.0 grams of pure copper? So let's look at how we would do this. So if we have 5 grams of copper, so 5.0 grams of copper. How can we figure out how many atoms we have in there? So here's what we need to do. The first part of the equation, you'll need to take grams of copper, and you'll use the periodic table right here to figure out your grams of copper, which you see this right over here, 63.546. However, do you remember, that's the grams for what? Is that grams for 1 atom of copper? No, that's actually grams for a mole of copper. So what will happen when you do grams of copper, you can only turn that into moles of copper. And so what happens, we're going to have, zoom in, see this again, 63.546 for every 1 mole of copper. So I'm writing that on my equation. So look what we have. 63.546, because that's what the periodic table says, for 1 mole of copper. The question, if you remember, said 5 grams of copper. It says how many copper atoms will we have? So for this is an equation that requires 2 steps. We're only in moles of copper. So then what we need to do is turn, because see, look, grams of copper will cancel out. Your answer would be in moles of copper. That's not what you want. So then over here, do moles of copper turns into atoms of copper. And then how do moles and atoms relate to each other? Well, remember, this is our first lesson in this. 1 mole is 6.022 times 10 to the 23rd. So it's starting to get off the screen, but it's 6.022 times 10 to the 23rd over 1. So that's our equation. So what we'll need to do is we'll need to do 5.0 times 1 times 6.022 times 10 to the 23rd. Then divide by the 63.546 and divide by 1. I am obviously going to ignore multiplying by 1, dividing by 1, because that doesn't change anything. So your equation will be 5.0 times 6.022 times 10 to the 23rd divided by 63.546. So I'm going to plug all that in the calculator. So we have, I'm going to slide it over so I can access it a bit better. So we have 5.0. Let's open up the little calculator thing so we can slide this over. Okay, there it is. This was, my screen was blocking it. We need this. So 5.0 times 6.022 times 10 to the 23rd. And this would be 3.011 times 10 to the 24th. Here's what you can always do just to be safe. We'll put this thing in parentheses because we want it to multiply the top line. If you're ever unsure of how your calculator is going to do things, just take all the stuff on top in parentheses and then divide by what's on bottom. Otherwise, what can happen, this calculator is a bit better because you can see whether you're dealing with what's up top. But sometimes if you just type it in, it might think when you do divided by what's on bottom, 63.546. This one's nice because it puts it on bottom. You can see it's doing the right thing. However, if you were typing it in a graphing calculator and you don't use parentheses, you might end up doing 23 divided by the 63. So you end up just messing with the exponent, and it could mess it all up. So here we do all this, and it figures it out for us. 4.74 times 10 to the 22nd. Okay, so that's what we get for that. So when we get to the problems here, how many atoms are in 2 grams of hydrogen? How many atoms are in 2 grams of helium? How many atoms are in 15 grams of carbon? How many atoms are in 15 grams of gold? So go ahead and do these 4 problems. It's using exactly what I did up there. So I will, so press pause. I want you to try these 4 questions, and then press play, and we'll go over them. Okay, so let's look at the first problem. 2 grams of hydrogen. So this time, the setup is going to be quite a bit different because it's going to be, I'll just erase the whole thing. It's going to be, we start with 2 grams of hydrogen. And so we can turn grams of hydrogen into moles of hydrogen. And we know that 1 mole of hydrogen is, I'm going to pull up the periodic table, and I'm going to look at H, and it's 1.008. So 1.008. And then we turn moles of hydrogen into 6.022 times 10 to the 23rd atoms of hydrogen. Grams cancel out, moles cancels out. Our answer will be in atoms. That's just what we wanted. So we'll end up doing 2 times 6.022 times 10 to the 23rd divided by 1.008. So let's plug that into our calculator. So it's going to be 2.0 times 6.022 times 10 to the 23rd. See, look, if I do divided by, it thinks I'm doing it just on the 23. That's why it's really helpful to do parentheses for everything that's supposed to be on top. And then divided by, and on bottom is going to be 1.008. And we get 1.19 times 10 to the 24th. So this was rounded right here, is 1.2. So there we go. Now it's 2.0 grams of helium. You know what I'm going to do? Watch how I'm going to shortcut this. It's 2.0 grams of helium. We'll end up doing 6.022. The only thing that will be different is the mass of helium on bottom. And the mass of helium is 4.003. So the only thing that changes here on bottom, we're going to do 4.003. And we get 3.0087 times 10 to the 23rd. That would be the 3.0 times 10 to the 23rd. Okay, now we have 15 grams of carbon. So watch what's going to change now. Now instead of 2.0 grams, we're going to have 15 grams. And the mass, instead of it being 4.003, the mass is going to be whatever carbon is, which is 12.011. And so on bottom, we will just have 12.011. And our answer here is 7.52 times 10 to the 23rd. So number 3, 7.52 times 10 to the 23rd. And then last but not least is 15 grams of gold. So now our calculator stays the same with the 15 grams, that many atoms, and then on the bottom we'll use the mass of gold. And we have AU, which is 196.967. So on bottom, 196.967. We get 4.586 times 10 to the 22nd. 4.59 times 10 to the 22nd. See how once you find the pattern of how you do this, it ends up feeling like the same thing every time, because it really is. You're just changing a few numbers. Okay, so that's how we can go from mass all the way over to atoms. And then the next thing we need to understand is something called molar mass. And what you do to find molar mass, you just use the ratios. So an example, if you need to find the molar mass of H2O, you know the hydrogen is 1.008. You know the oxygen is 16. Oxygen on our periodic table is 15.999. You could round it to 16 though. But all you would do, if it's two H's, you would just take 2 times whatever the mass of H is. Plus, in this equation, there's one of the O's, so 1 times whatever the O is, and then you add them together. So if we need to do Al2SO4, so what it's going to be, we have Al2SO4. So let me erase this. So really, it's just going to be, let's look at this first. We have 2 aluminums. How many S's do we have? You might be tempted to say only 1, but there's 3 because that 3 applies to everything there. How many O's? You might think 4, but there's 12 because 4 times 3 makes 12. This 3 right here triples all of those. So it's going to be 2 of whatever aluminum is, plus 3 of whatever sulfur is, plus 12 of whatever we get for oxygen. Okay, so look at what I set up before I've even looked at the periodic table, because I see that there's 2 aluminums, so 2 times the mass of aluminum, plus 3 times the mass of the sulfur, plus 12 times the mass of oxygen. And then we're just going to plug them all in. So look at the periodic table. And so we have aluminum, 26.982. Sulfur is 32.066. And then oxygen is 15.999. Okay, and then, so let me zoom out. I'll let you see everything that I have set up. So right there, 2 times 26.982, 3 times 32.066, and 12 times 15.999. Let's go to our calculator, and let's just plug all that in. So it's just 2, and we have 26.982 plus, and this time we have 3 times 32.066 plus 12 times 15.999. Look at our molar mass, 342.15. So that's how we find molar mass. And then I want you to try to do that, and you're going to do 5 through 8. Find the molar mass of H3PO4 and A2CO3. So try to find all these molar masses, okay? So press pause, try to do 5 through 8, and then press play to see me go over it. Okay, so for this, I'm just going to do it straight on the calculator. So it's 3 times H. So 3, we know H is 1.008 plus E, phosphorus. I need to look that one up. I don't have that one memorized. 30.974. So 1 phosphorus, so plus 1 times 30.974. Obviously, writing the 1 in front is totally redundant. I'm just doing that so I follow the pattern I've laid out for you. And then 4 oxygens. So 4 times 15.999. And we get 96.994. 96.994. Moving on to number 6. Sodium, Na, is 22.990. So now for sodium, we have, was it 2 of the NAs? Yeah. So 2 times 22.990 plus, was it 1 carbon I saw? Yep, 1 carbon. 1 times 12.011 plus, I think we had 3 oxygens, 3 times 15.999. and we get 105.988. 105.988. Number 7. So this time, so remember this 3 triples everything in here. So really this 2 turns into a 6. This 4 turns into a 12. And then instead of doing it a bunch of times, just add it all together. So there's 6 carbons right here plus 1 more. There's a total of 7 carbons. So let's do right here 7 times 12.011. And then look right here, we have oxygens. 4 times 3 makes 12, plus 2 more, so 14 oxygens. So plus 14 times 15.999. And we have 308.063. 308.063. And then lastly, NH4Cl. So we're going to have 1N, 14.007. So 1, 14.007. And it's H. So plus 4 times 1.008. Plus 1, was it 1 chlorine? 1 chlorine. So 135.543. Let me double check, make sure I have that right. Chlorine, 35.453. 35.453. And you get 53.942. 53.942. There you go. All right, so that's how we do this. Make sure that you try those and get those right and understand how to do them. And that's it for the lesson. So have a good rest of your day.